Hello, this is the retake ticket for learning target V on using arithmetic and geometric sequences. We're going to look at some questions here together. It says, write an explicit rule for the nth term of a sequence and then find the 12th term. So if we focus on question A here, the first thing we want to do is identify the right pattern. And as I look at this list of values, I can see that from 4 to 2 we are adding 6, and from 2 to 8 we are adding 6, and from 8 to 14 we are adding 6, which tells me that this is arithmetic with a common difference of 6. So as I examine the formula sheet, I see that I have a formula for an. I'll write that formula down here for us. We've got an is supposed to be a1 plus d times n minus 1. So all we have to do is plug in a1, which is -4, plus our common difference, which is 6, times n minus 1. And we can use that formula to find the 12th term. The 12th term is going to be found by plugging in 12 for n. -4 plus 6 times 12 minus 1. Use the order of operations. 12 minus 1 is 11. 11 times 6, and then subtract 4, you get 62. Part B is very similar, but the pattern has changed. Instead of adding, we're multiplying. We're multiplying by 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So this is geometric where r is 3, and if you look in your formula sheet, you will see that an is a1 multiplied by r to the n minus 1. So my formula, as I write it down, is going to be a1. Now you can find a1 right here, the first term. a1 is going to be 3, and my common ratio is also 3. So the 12th term is going to be 3 times 3 to the 12 minus 1. And that is a number that is just over 500,000, 531,441. Moving on to question number 2, it's asking us to write, instead of an explicit rule, it is asking us for a recursive rule. And recursive rules, there's one of two types. Either you've got geometric or arithmetic. So let's look at 2 examples where we have one of each. You might notice that in this pattern, in part A, we have a pattern where we are going up by 2. Well, that makes it very easy to write the recursive rule. Recursive rule is going to have 2, count them, 2 parts. The first part, you have to write down the first term. Many of you on your first attempt forgot to write down the first term. It's very simple. You just have to write it down. a1 is equal to whatever number you see first. You can find that right here, first value. Write it down. a1 equals 2. Then the second term is 2 bigger, and the third term is 2 bigger than that. So the nth term is the previous term. Now remember the notation we used for the previous term. It is an a sub n minus 1. And since we're adding 2, this is what I want to add 2 to. And there's our result. Both parts have to be there. Did I mention that you need to remember to write down the first term? That's important. The second pattern I'm noticing that our signs are changing, and the fact that the sign is going negative, positive is a near dead giveaway that we are multiplying by a negative. We are multiplying here by -5. Same thing from here to here, multiplying by -5. So A1 is -3, and AN is A sub n minus 1 multiplied by -5.